Welcome to SAT 0 to 1. In this lesson, we'll be learning about the confidence interval and the margin of error. The confidence interval is a range of values that's likely to include a true value with a certain degree of confidence. And the margin of error is the degree of uncertainty that your estimate might have. The definitions sound really scary, but I'll show you a very simple example about what those two terms actually mean. So suppose we need the average height of students in a certain school. Wait, there are not enough students right now? Okay, now we have enough. So if we want to know the average height of every student at the school, it would be very tiresome to measure everyone at the school. So what we can do is to take a sample of the students and then use the sample average to estimate the population average. Say the sample average of 10 students is 1.75 meters. It would be very unlikely that our sample is a perfect representation of the population. So we need to allow some degree of uncertainty in our estimate. And the uncertainty is called the margin of error. Suppose with the help of advanced statistical concepts, we calculated the margin of error to be 0.03 meters. Remember that the confidence interval is just equal to the sample mean plus or minus the margin of error. So after carrying out the addition and after subtraction, we have the confidence interval between 1.72 meter to 1.78 meters. What we really mean by this is that we're pretty confident that the true mean height of every student at this school fall between 1.72 meters and 1.78 meters. Now, when we have questions about the confidence interval, there's one very important point we need to keep in mind. It is that the interval is not 100%. That is why we always have to use non-deterministic language. Remember I said earlier that we're pretty confident that the interval contains the true mean. Here, confident is not 100%, so I cannot say something like, I'm absolutely sure that the interval will capture the true mean. Let's now look at how to reduce the margin of error. Well, first of all, we need to know where margin of error came from. Each time we take samples, we cannot guarantee that the sample is a perfect presentation of the entire population. For example, when we select these three individuals, notice one guy from the very left is much taller than the other two. So comparing to the sample mean on the right, the red sample mean will obviously be higher than the blue sample mean. And each time we take samples, we will almost always get different results. That is why we need to include the margin of error in our estimation. And one way to reduce the margin of error is pretty straightforward. We increase the sample size. By increasing the sample size, we say that the tall guy on the left will be evened out by all other 9 individuals in the sample, and thus will not impact the sample mean as much as when we only had a sample size of 3. Another way to improve the margin of error is by increasing the data quality, or to reduce sampling bias. Suppose in our study for the average height of students, we accidentally included a teacher in our sample. Now, of course, it is possible that the teachers tend to be taller than the students, and so this teacher could contaminate the entire sample and thus cause a rise in the margin of error. Well, to reduce the margin of error, we can just exclude this teacher from our sample, and thus the data quality improves and the margin of error will be reduced. And so remember, to reduce the margin of error, we want to increase the sample size and improve data quality. Okay, now we have a basic understanding of confidence interval and margin of error. Let's take a look at this practice question. A soda company sells cans of soda. A random sample of 10 cans of soda found that the cans contained 0.52 liters of soda, and the estimate had a margin of error of 0.09 liters. Which of the following is a reasonable claim based on this sample? The fact that the question involved terms like estimate, margin of error, and the fact that all the choices involve an interval, we should know this is a confidence interval problem. So according to our formula, the sample mean in the question is 0.52, and the margin of error is 0.09. So we can compute the confidence interval to be 0.43 to 0.61. So we have two possible correct answers here. It's either C or D. But remember earlier we said that the confidence interval is not 100%, so words like always cannot be used. And therefore the correct answer is D. It is plausible that on average, note how we are using non-deterministic language, the company fails its can within this confidence interval. Let's move to the next practice. A researcher at Gauthmath wants to estimate the average time it takes their AI to solve a typical high school math problem. Which of the following sample would lead to least margin of error? Remember, in order to reduce the margin of error, we want the large and representative samples. Choice C and D have the largest sample size, 200. But choice C is more representative than choice D, because remember in the question, our goal was to estimate the average time for a typical high school math problem. Therefore, we need high school math problems, not university math problems. Okay, let's move to the next one. A study has shown that a certain disease has infected 20% of the population in a town with 10,000 people, with a margin of error of 2%. If X is the actual number of people who were infected, which of the following is most plausible? Well, the phrase margin of error and the most plausible suggests that we're facing another confidence interval problem. Firstly, we can just calculate the interval for the percentage of infection, which is 18% to 22%. And to find out the actual number of people who were infected, we can just multiply the percentage by the total population in the town. And finally, we arrive at the answer 1800 to 2200. And the correct answer is C. Well, that's it for this lesson. I hope it helped. Thank you for watching. Until next time.